Okay, welcome everyone for like a talk on AI for pen testing. This will mainly be a literature review, but around the end we will talk a bit of the work we are trying to do. So yeah, we will start with like the motivation of this work and like what is even pen testing, and then we will kind of like walk through like one hacking procedure just to see like what it's like and like the difficulties there. And then we will go through a paper called Pentest GPT, and then around 3 papers by the University of Illinois Urbana-Champaign, and then LLM as hackers, autonomous privilege escalation, auto attacker, and then finally we'll talk a bit about our own research and contributions. Okay, so the first question that there's a ping. Oh yeah. The first question that I think people have is like, what even is pen testing? So like every computer, when you connect to the internet, has an IP address, which is like the address of the computer. So the idea is you first like scan the IP address to find like vulnerable services, and then you exploit them to gain access to the computer with that IP address. And then finally, you kind of like elevate your privilege so that you have super user permissions, which basically means you can do anything on the computer that you want. And kind of like a question of like why even like research this, and the reason is there's kind of like a growing sense of like lack of security from hacking, you know. Like, for example, there was a recent social security number breach in America. So, like, pretty much all of your social security numbers, if you are, like, ever visited America or, like, has a visa in America, is leaked. Or, like, if you use Hugging Face, there was, like, some secrets exposed and stuff. So, like, there's a general, like, lack of security against hacking in the current world, at least in my opinion. So, one kind of like dream that a lot of people in this field have is the dream of auto pen testing. So pen testing basically is like hacking, but like it's like hacking by like ethical hackers, kind of. So basically the idea is let's try to like hack into the machine, and for all the exploits we find, we can just keep patching them. And what auto pen testing is like a automated version of that, where there's no human in the loop. So like you can just have the LLM test your machine, and then it can say, oh, these are all the exploits that we found, so that you can fix them. And yeah, there's like massive amount of money that is riding on this. Like for example, DARPA and stuff spent around $4 million on like AI cybersecurity challenge to attempt this. I don't know like how promising the top results were, but like there's definitely like a lot of like interest in this field. But yeah, let's look at like what pen testing looks like, and here Manil will take over. Yeah.
Thank you. Thank you, Chad. Yeah, in this part, I'm just gonna go through a hack the box machine called Wave Vortex, which is a easy box to hack through. But yeah, we're gonna go through each step how a hacking procedure normally works to just get the audience, understand how non-trivial the hacking task actually is. Can you go to the next slide? So yeah, so this is a hack the box machine. So when you're starting to hack, to do any sort of penetration testing, normally the first step is to find what ports and what services are active in a machine. So we use the command called nmap on the IP, and we find out there are 2 ports that are active in this particular machine. So this might be variable. There might be all 65,000 ports active, but in this particular machine we had 2 ports active: the port 22, which is for SSH, and we have 80, which is for HTTP service. Now, since we know that 80 is active, we can assume that there is a website hosted in this particular server. so that we go to the website and try to see. So this step normally is called web enumeration. Um, yeah, the next slide. So during the web enumeration, our main task as a hacker or penetration tester is to find any key information that we can gather that could be used in order to exploit the system, right? So HTMLs tend to have bunch of links. Like if even if you, I think it's a little tiny, but you can see that there are a bunch of links at the top, and each of them will have their own sublinks. So if you want to do curl and want to like go through each and every links and send that to LLM to analyze, it tend to become like more expensive, but not always a fruitful exercise. And so in this case, we use, next slide, please. Instead of going to all of the sublinks and trying to find out, like checking each and every HTML, there is, in this particular machine, the correct next step would be to brute force over the vhosts to discover valid subdomains. So within the dev vortex, we want to find if there is any other services running in this website. So we use fuff, this particular command, and this program just brute forces over the vhost dev vortex. And the important part that I want to highlight is that in order to use FUF, this is a brute force technique, so we need a word list. So choosing the word list depends on the task. For example, this is the task to discover valid subdomains. So we need to use a particular word list called, the Bitquark subdomain. Since we normally we do with we are in the Kali operating system, like these are pre-installed, these word lists, but you can download them from website, like from the net. And doing this, we find out that okay, this dev vortex server, this dev vortex website has a subdomain called dev. Now let's go and enumerate that. Now if we go to the devvortex.stb, we can see that okay, now we need to find if there are any additional subdirectories that we can enumerate and try to find out any vulnerabilities that we could exploit. So the next thing, we again use FUF, we do the brute force to find out the possible subdirectories. Now the point to note is that now the word list is different. Now we are using a different word list, the called directory list, and then we use this brute forcing technique to find out that there is a subdirectory called administrator. Now, this administrator is where you find there is a Joomla login page. Now, we know that this Dev Vortex website is hosted on Joomla CMS. The next important step is to find out if there are any known exploits for this particular Joomla version. And we go to exploit DB and just try to find out what kind of the released exploits are there. But in order to do that, we need to know what version of Joomla it's running, which is another task to enumerate. And this part, we noticed that LLM was having a little difficulty in finding out the Joomla version, and we had to Google that Joomla, the administrator manifest files, Joomla.xml has this information. And by going to this particular file, we find out that it's a Joomla version 4.2.8. And then we go back to the exploit DB, search for Joomla CMS version 4.2.8, and then we find a Ruby script for the particular vulnerability that allows unauthenticated attackers to disclose the information. For example, we just download this particular exploit, we run this for the URL, and then we find out that the administrator user and password for the CMS admin login. It's a the user password just to get into the CMS. Now, since we are into the CMS, normally what we have is we have the capability to inject some sort of malicious code or upload some malicious files, right? So we can enumerate through the browser for this particular CMS and go to the site templates, go to this Cassiopeia details, which is specific to this particular box, I think. And then we have files, then you can add and edit. So being able to add and edit, as I mentioned, is a very important step, because you could inject it with malicious code. You can upload some malicious file. In this scenario, we found that we can only edit the error.php file without erroring out. Like there was some sort of security measures in place that you couldn't edit the index.php without erroring out, or we couldn't upload the files. There was some security measures in place. So the only option was to edit the error.php file. And then we could just go and check out what sort of any sort of reverse shell. So now our next task is to get into the machine through shell. So in order to do that, what the next correct task was to put this code injection into this server through the error.php file. So we add this, not without replacing anything else, we add this code in the error.php. Then we start the listener. So the thing with cell construction, normally it's a very standard procedure in penetration testing, where instead of you connecting to the server, you just open a listener on a certain port on your machine, and then when you run the infected code in the server, the connection between you and the server is made. So in this scenario, what we did was we opened a port at 4444 in our attacker machine. We started listening to it. We executed the reverse shell, and you can see in the reverse shell there is attacker IP. Sorry, I don't know if I can annotate. It's fine. So yeah, Isamu, can you there is a mention of attacker IP within the poison command, right? So this is your IP that you are trying to connect from. So you listen to 4444, you execute the reverse shell by just doing curling, or you can go to the exact link. Then what happens is it executes the poison, and you just can connect with the server. Now you are in. But our task is not done yet, because even if you're in, if you just check your sudo privileges, there is nothing very important commands that you can run through sudo. So what we do now next is we need to get into, that's our main goal for the whole task of penetration testing. So in order to do this, the next step that we followed was, okay, is there any SQL database being hosted in this website? So we find out by checking by running this ss-tlpn to find out which port is running MySQL. And then since we already know this Lewis's credentials through the Ruby exploit that we had earlier, we connect to the MySQL database, and then we find out that there is an interesting table called SD4FG users inside the database called Joomla. And then we see that, okay, there are username and passwords there, but it's all encrypted. Now, the next step is to find out, to decrypt this message, right? To decrypt this password. And the key detail here is to identify that this is a bcrypt, and it requires the hashcat mode 3200 to get the exact result. And we just use the hashcat tool, which is pre-installed in Kali, but you can obviously install it on your machine. And then you just do the reverse hash. You decrypt the passwords using. So here's another point that I want to note. Like you need to use a different word list here, because you're trying to brute force. I mean, you're trying to find out the password from the hash. So you do hashcat with the different word list called ROCU, and you discovered the credentials for user Logan. Now we can now we have the SSH username and password for the username Logan. But the story is not complete yet. Now we log in with Logan on this victim IP, use the password that we just decrypted, and then we see that, okay, are we root yet? We do sudo L, sudo/l. Then we find out that, okay, we are not root, but we do have sudo privilege to run this particular command called apport CLI. Now, what's apport CLI? I was like, okay, I went to Google and saw, okay, apport CLI is it's used in Ubuntu Debian-based Linux OS for handling application crashes, collecting crash reports, viewing it, sending it, and we have sudo privilege to run this as a Logan. Logan has it. Now we are Logan since we just logged in as Logan. Now you can just check for the CVE, the exploitation through Apport CLI, and we found out that when you use this Apport CLI through sudo, and you view the report, you get a VI like interface. You get a Vim like VI kind of interface, which if you just, you can run the commands, right? You can do exclamation and then you can run the command. So since you ran this as a sudo, and if you go to the just execute the bin bash command, now you create your own shell with sudo privilege. You can check sudo/l and you can see that it has privilege on all the code to run as sudo. Now the penetration testing is successful, I would say, because now we are root. So this whole walkthrough was to introduce the audience that the process. This is an easy box. Just to reiterate, this is an easy box, but there's still, it's a non-trivial task. There's so many sub-steps, so many steps, and there are so many different paths that you could explore. But we just mentioned in this slide, in this presentation, we just went through the correct way to get to the root privilege. So I would like Chad to just take over from here.
Thanks for that part. Yeah, does anyone have any questions? Oh, so that was the reason we selected login as the login is because that's the only other user that we could find in the MySQL. So like, if there's other users, we can try those. But basically, we wanted somebody other than the default Louise one because Louise doesn't have any opportunities to go to root, basically. But yeah, kind of like I know that was pretty complicated. So like, but I don't feel pressured to like understand everything. That was just as Manil said, as like a way to, as like a brief introduction to hacking and like understanding how difficult it can be, basically. Okay, so yeah, let's go back to let's go to a summary. So the main difficulties that we identified for LLMs is that navigating the websites can be hard. So like, or basically any step where you search for information can be hard. For example, Googling the right exploits, or like, let's say you have a pure HTML, right? For auto pen testing, we want the LLM to do everything. So the LLM needs to view like sometimes up to like 8,000 lines of like HTML code to identify like which is the vulnerable parts and stuff. Or like if you're like navigating through like a Linux system or something, you have to like go through like so many. You might have to go through like so many files and like so many like millions of files and millions of lines of code or something to like find like the right places, or like basically it's very hard for the LLM to know which files are the right files, kind of like that. Also like here, at least in this case, in this easy box, setting up the reverse shell required some kind of like non-trivial configurations. Like you can't just edit the error.php file to be like a typical reverse shell by replacing everything, because then it won't run or something like that. And also like the previous escalation, like Manil brushed over it a bit, but like finding out that you can exploit it using crash reports, I don't think it's I think it requires some research on the end of the LLM, or at least kind of like an ability to use Google and like understand the results. So yeah, I'm just saying that I just wanted to say that pen testing or like hacking is not immediately kind of like knowing exploits and applying them. It's kind of like there's a lot of process of like finding out what's vulnerable and like how to like exploit those vulnerabilities and stuff. Like exploiting is probably one of the easiest parts of pen testing, at least in my opinion. So yeah, kind of like let me go into a bit of a penetration testing cycle. So this is an image that I got from like a Discord server called VitalBit which is basically a server dedicated to like building open source cybersecurity LLMs. But there are like many free steps to pen testing. There's the enumeration, which means the information gathering. There's the exploitation, which is exploiting those kind of vulnerable services that we found. And finally, there's privilege escalation. Now, kind of like you might say that, okay, once we are done with step 3, we are basically done, right? But the answer is no. Sometimes like we have to like, we only exploited one out of like 50 vulnerable machines. So then we have to like start enumerating one new machine and so on. So like this is just a cycle. Like sometimes it's like enumeration, exploitation, and then we keep enumerating, and then we find another exploit and we exploit, and then privilege escalation, and then we go back to enumeration, something like that. And usually the more we do this, the more like cycles we do, the difficulties are harder. So and yeah, as I said, in my opinion, the hardest step is enumeration. Yeah, any questions so far? Okay, I believe the current reasoning level can also stumble on it. Yeah. Excess hit, therefore I should also. Yeah, definitely. I kind of like, in around the 4th paper, I think I will go into that a bit, because the authors also, some researchers also identified that issue. So yeah, so like the first paper that I wanted to highlight, and also the first paper I read on this topic, is a paper called Pentest GPT. And it's basically like a LLM-powered automated penetration testing tool, as the thing says. And basically, the claim that they had was this method, this agent method, can get into the top 10% of hackers. So like, out of all the hackers that can hack all these easy boxes and medium boxes and hard boxes, this kind of like just simple prompting GPT-4 and stuff can get into the top 10%. So how does it work? So first of all, they have the parsing module, which basically, once you have the command outputs or like the HTML outputs, you kind of like pass it to this parsing module to summarize it. So this will kind of like remove a lot of like the issues of like having like too much input to handle, so that because it's kind of squashed, so that it's kind of readable by the LLM. Next, given this output from this parsing module, there is a thing called a reasoning module, which kind of like, given this summary, updates like the to-do list. Oh, actually, can everyone like see the slides I shared? Okay, I guess not. Sorry, Manil, can you approve those requests? Sorry. Oh, can you?
Yeah, sure, I'll try.
Yeah, thank you. Yeah, if everyone has like a view request, that would be great. But yeah, so the parsing module summarizes. The reasoning module, basically it has a to-do list, and which they call the penetration testing tree. And actually, I guess I can. Actually, I'll do this. I think Manil did. So basically, this to-do list, given this new information from the summary, updates the to-do list to say like what's the next in progress task, basically. So, and finally, this generating module, given this task from this to-do list, says like, okay, what's the next step? Or it says like, what are like the things you have to do this task? So basically, this summarizes, this chooses the next task and like adds new tasks, and this kind of like explains the step-by-step things you have to do to execute this task, and then it goes all the way over again. So this is the basic idea. now then, how is it possible for them to kind of like claim that they're in the top 10% of hackers? So yeah, let me explain how even normal hackers, like normal human hackers, evaluate their skills. And the two main ways that this Pentest GPT highlighted was Hack the Box and Bound Hub. So Hack the Box, which the above machine that we went through, the Vortex, was a machine on this site called Hack the Box. And it's basically like a lead code for hackers, where basically you have this IP address, and then you try to hack into it. And to prove that you finished hacking, at the end, kind of like, once you have root privilege, you will have like permission to view a contents of like a file that only like the super user can view. And then if you kind of like, if you just view that contents of the file, you'll get the hash, which you can put in here as a flag. And then if you submit, you get points. And there's like a leaderboard, and like, if you become in the top 1% or something, you can get hired and stuff. So basically, this is like lead code for hackers. And yeah, the main pro of this is that it has like a well-defined difficulty. Like each user can rate the boxes on how difficult it is, and they can have a leaderboard. They have a massive community, and also a Discord server. And also the machines and penetrations are very realistic. Like you won't see any like hints and stuff in here. But kind of like some of the issues that I found personally was that it requires VPN connections. And sometimes for the VPN, you can only actually run the boxes properly if you are connected to the European region, which I thought was a bit ambiguous. And also like this site separates active machines from retired machines. And basically what that means is like for pretty much all the active machines, you can work on them for free, but you are not allowed to like post walkthroughs on them basically. Because basically we don't want any like spoilers for other people doing the active machines. And for retired machines, they are like, the only way to access them is to pay Hack the Box, like $14 per month. And then you can work on them. And usually like every active machine eventually becomes retired machines. Yeah. So on the other hand, like Bound Hub is like it's like a open VirtualBox lab sharing website, where like a lot of people like upload their own like virtual boxes with like certain vulnerabilities, and like you can just download them and work on them through VirtualBox. So yeah, as an example, I have a bit here, like all these are Bound Hub machines, and I can open each, and then I can open this Kali Linux and start cracking. But yeah, so the pros of them is like every single virtual machine here is free, and also there's a massive community here as well. But the con is like difficulty can be like a bit subjective. So like there's like a GitHub repository that classifies difficulties, but like the most recent Bound Hub box that they have is like from 2020. So like other than that, there isn't that much measure on like how each box is difficult versus another box. And also sometimes the labs can be a bit like a game rather than like a realistic pen testing environment. For example, the authors can have like hints in the HTML source code, or like something called steganography, which is like given this image, there's like a secret code hidden within it, which I don't personally think is much realistic. Yeah. Yeah. Any questions so far? Oh yeah. So how did newly current hacking paradigm consider? I think like this is a pretty interesting point. Like sometimes like there's like a new like exploit or something found, which kind of like makes all these boxes trivial, where like you can just hack into them immediately without anything. I'm not saying post-quantum stuff will do that, but there is a case like that, which then makes which then means like you have to have new boxes basically. So you always have to have the most updated, like most patched box in order for these to work. And could run the thread. I'm not sure what that means, but yeah, let me go back. So yeah, so now that we kind of like talked about these two services, let's go back to Pentest GPT. So what the authors did was they selected 7 easy boxes, 4 medium boxes, and 2 hard boxes from both BurnHub and HackTheBox. And then basically they ran it through GPT-4 without Pentest GPT and GPT 3.5 and BARD. And I think like one interesting thing that I wanted to point out here is that GPT-4 was by itself, they claim was able to solve 4 easy boxes and 1 medium box, kind of like pretty much by itself, which is pretty impressive. Like basically it's saying that it was able to beat 4 of those vortex boxes and also 1 medium box, which is a higher difficulty by itself. So, but also like another thing that I wanted to point out is like there's these things called subtasks, and like basically one question you might have is like what even is subtasks in this context? So subtasks are basically like here because we want to evaluate partial completions of boxes, and as the paper puts it, it's like each subtask is like a well-defined kind of like step in the guide, which is like network discovery, like nmap. Actually, not nmap, but like finding the IP address, or like password cracking, like brute forcing or something. So it's kind of well-defined like that, and like and it can evaluate like and a string of those can kind of like evaluate like partial completions of boxes, because every box is composed of these multiple steps. But like, I think one question that you might have is like why do we always know that it's like one single path? Like, can't it be possible to like beat a box in one step, like using a single bit exploit, or like another path can be like 1,000 steps where there's like 900 like completed like useless steps, and kind of like or kind of like more realistically, can't like a single path, like for example like that previous escalation path, be done in like multiple different ways? And the answer is yes, it can. So what the authors defined here was pretty interesting. They've defined something called a task boundary. So like if like there's like they kind of had like 3 pen testers independently do all the boxes, and then if they saw like a place where they deviate, they kind of like put all the deviations, they kind of like set up the task so that all the deviations is within one task, kind of. Like for example, if there's we can log in with HTTP brute forcing, or like where you brute force a username and password, or also like if you can kind of find a hash on like the somewhere in the emails, and then you crack that hash locally, both of those can be within the same task. So like all those deviations can be like represented by a single task, but like there can be like multiple ways to do that single task, basically. Yeah, does that make sense? How can advanced technology such as reinforcement? That is definitely a good question, but like we are definitely there are some papers that kind of like try to do reinforcement learning stuff, but I don't think we are quite there yet, because at least kind of one thing I wanted to show through this presentation was that there's a bit of like there's no like standard evaluation process currently. So I don't think there will be a standard reinforcement learning method yet. Yeah. So yeah, that's like the explanation of subtasks. So yeah, actually, sorry, these are duplicate slides. But how does like LLMs perform on this benchmark? And without Pentest GPT, it's like this. But with Pentest GPT, so like this is, yeah, kind of like they didn't have it in the same table, so it's a bit hard to see. But for GPT-4, it was able to beat 4 out of the 7 easy boxes without Pentest GPT. And with Pentest GPT, it's able to beat 6 out of the 7. And here, it was only able to beat 1 medium box. And here it's 2. And for hard boxes, neither this nor here was able to beat any. But still, it's like a pretty impressive thing. Like it was able to beat 6 of those Dev Vortex boxes and 2 like boxes that were even harder than Dev Vortex, which I thought was pretty impressive. But yeah, kind of like, yeah, basically let's go to the slide criticisms I had of the paper. So the benchmark that they currently have cannot be accessed, although they do say they want to open source it. Apparently they are withholding it until like until the conference accepts the paper and stuff. And also like but another person did make like a reproduction of the Pentest GPT benchmark, which you can access here, but it is not the official one, as like some of the vulnerabilities are missing. Also, they also kind of like uploaded some videos of Pentest, like the authors kind of like testing out Pentest GPT on their machines. But at least in my opinion, I think it showed some that the evaluator had to have a bit of like pen testing knowledge in order to evaluate the benchmark. So there's a bit of a So the main claim is that the evaluators were giving more assistance to the Pentest GPT than is apparent. And also, it's a bit unclear when the LLM or the agent fails. Like, let's say over the course of the benchmark, it outputs an invalid command, then if we just give it the output of that invalid command and ask it to correct it or something, like let's say for like 10 times, at that point, did it fail, or like should we keep going? Like the paper is a bit unclear on like at what point should we say that the LLM agents failed on this benchmark? So like some of the stuff so this is like the video of Pentest GPT performing on like Hack the Box Jarvis, which they uploaded on the GitHub. And one of the stuff I found was like, for example, in the terminal output of like the directories, the pen tester said which directory looked interesting because he knew that this has a vulnerability. And also like he said that, sorry, it's not PHP injection, it's SQL injection. He said that he went to the URL and tested it out, and he pretty much independently said that it's possible to do SQL injection on it. And also like, sorry, I kept saying PHP injection, but it says that it's kind of like when the LLM went to a different path, the pen tester kept saying, let's do more SQL injection. And then if the command for the SQL injection stuff fails, he was able to say that it was because of the firewall without the LLM telling him to. Also, like he found that the key parts of the terminal, he kind of like cropped part of the output of the SQL map, which is a command, which he found interesting to give to the agent. And also like the pen tester found the exploit online and like read it and then executed himself with like a custom payload to like open a reverse shell on the machine, which the LLM didn't give to him. So like, I think it can be argued that this is without bias, but like, I did find that it did kind of like seem as though the pentest was helping the Pentest GPT. And it's a bit unclear that for these boxes, like whether it was Pentest GPT that performed this well or the pentester who was running the benchmark. Yeah, and I think an interesting question here is like, is it even possible for the evaluator here to not be biased? Like, for example, if you're like looking at a website, right? The best way to not be biased, or like when doing web enumeration, is to give all the HTML to the or all the HTML of like all the possible pages to the LLM to find the vulnerability. But that will like consume so much tokens, and I don't think it's obvious that it will perform well, and at least it will be extremely expensive. So like, if I say like I found a login page at this location, will that be biased? Like that'll be like I don't think it's as biased as in this case, but like I do think there's a bit of like discussion of like how much human involvement should there be in the benchmark. Yeah, any questions so far? Amount of boxes beaten. Are there other types of vulnerabilities or exploits that the element? Kind of like one thing I found is that for the exploits, kind of like if they are like especially old, like old code or something, or like if it, for a lot of exploit descriptions, they can be a bit unclear on like what exactly they want, or what exactly are the steps to execute them. So in that case, the LLMs struggle a bit. But like, let's say for like new exploits, like around 2024 or something, I think most of those exploits are like easy to understand. So the LLMs will have an easy time. How can mishandling special token? Like that. I'm not sure. Actually, I probably should check this out later, but it seemed like more like LLM jailbreaking, right? More than like pen testing with LLMs, I think. Yeah. Then yeah, next. Okay, so kind of like this is a question like how much human involvement should there be? And for the next 4 papers or so, the authors mainly only looked at cases of auto pen testing, where there's absolutely no human involvement, and you try to like completely hack into the machine by the LLM by itself just tries to hack into the machine, basically. And yeah, so and the next 3 papers will be from a team at the University of Illinois Urbana-Champaign. Yep. So the first paper that we'll look at is LLM agents can autonomously hack websites, which is a pretty bold claim because, as I said, that each HTML can be like so large. So yeah, let's see like what they do. So yeah, so kind of the first thing that they used was something called Playwright, which is a Microsoft open source package where you can basically interact with websites by like you can write code in Playwright to like interact with websites, like logging in and like inputting stuff into input fields and stuff. And it was so popular that it was used in like the Red Rabbit Neo thing, where like basically they use this to like interact with GUIs and stuff. Yeah, basically it was this package. And how they did it was basically they set up a queue of all possible websites that they are interested in. And by interested in, they mean it has to have input fields or buttons or links. And then they remove like unnecessary HTML tags like for this machine, like the head, style, and script. And like for each website, they try doing SQL injection. They try doing SQL injection with a code that the LLM generated in Playwright, basically. And then the LLM is asked whether the SQL injection was a success after the Playwright code executes. So like, yeah, basically it's like going, and then there's 5 trials of this, which means like every time it fails, it says, this was a Playwright code, it failed like this. How can we improve it, basically, for 5 tries? And then it tried to do SQL injection. and these are like the success rate of each part. I want to explain all of these vulnerabilities and stuff, but the authors uploaded some code for this paper, and the only code there was for SQL injection, which I guess the reason they shared that was because it was 100%. But yeah, for all the others, I didn't have access to the code, so it might be different. But at least for SQL injection, it followed this procedure. Okay, so basically after this paper was published, there was like a blog post by a person called Chris Rolfe, which is saying no LLM agents cannot autonomously hack websites. And the slight criticism he mentioned was that basically this assumed, actually this is my one, but yeah, basically like it assumes that we already have SQL injection, which kind of like completely skips the enumeration process. And then after that, basically they are like open source tools where you can kind of like, if you know it's vulnerable to SQL injection, there's like open source tools to like, with a bit of human manual stuff where you can brute force or SQL stuff and pretty much achieve the same result. So like, so basically he's kind of questioning whether it's like even like important to do this in LLMs, which I think is a valid criticism. And also like, yeah. Also, this is like very expensive. Like you have to go through like every single web page in the website which has input fields 5 times, and that's like so many tokens. So like, I think a main improvement for this paper can be like if it can use like commands like SQL map and stuff to do SQL injection using open source packages and stuff, it might end up with like better. It might be like way cheaper at least, and maybe like less criticism worthy. But still, I do have a critique that the authors went into this with the assumption that SQL injection works, and yeah, exploiting I don't think it's like the hardest part. Like I think like finding out whether there's SQL injection might be a bit harder. So yeah, that's my main criticism. Okay, so after this paper, the authors published another paper called LLM Agents Can Autonomously Exploit One-Day Vulnerabilities. And I think the authors changed a tiny bit. Yeah, crazy. Yeah, a tiny bit. But basically, now the LLM is exploiting one-day vulnerabilities. I don't think necessarily in websites. Actually, I think this is still in websites, so yeah. And kind of like one question that you might have, as I had, was what is even like one-day vulnerabilities here? And one-day vulnerabilities is like vulnerabilities that were disclosed but not patched by the system. So essentially, this also doesn't require any enumeration because we already know that the website is vulnerable to this exploit. And for it's like a bit of an advanced version of the previous paper where like I had a critique that it didn't do SQL map, but in this case it can. It can kind of like do like, it's able to do web searching. It's able to use a terminal. It can kind of do web browsing elements, which I think uses Playwright. It can create files and edit it, and it also has a code interpreter. So it's like a super powered version of the previous one. And also like React was used, which is like this agent framework that kind of like started pretty much all agents, which is like thought, action, observation, thought, action, observation, I think. Yeah. Yeah, any questions so far? How could a global scale LLM powered cyber offensive be? I don't think we are quite there yet. Like, I think it's always better for humans to do it rather than AI, at least for now. And yeah, I don't think we are quite there yet. Apart from the multi-agent pipelines for pen testing, are there any readily available datasets or source to create such dataset to fine-tune them? Kind of, yeah. Actually, let me get back to you at the end. But like, yeah, there's like this team called White Rabbit Neo who like try to make open source LLMs, and they release like a tiny bit of the data set, so it might act as inspiration. But I don't think their method works as well as, say, GPT-4 and stuff, because for pen testing, you have to have long-term planning and understanding, which only seems to be possible with like GPT-4 or like very high parameter models, which is not the case for White Rabbit Neo. Yeah. Yeah. So basically this is like what they did. They added more like high power stuff, and also React agents was used. And yeah, these are all the vulnerabilities that they tested against, which I was incorrect. I think these are all web vulnerabilities. But as you can see, all of them are after GPT-4's cutoff date at this point in time. And yeah, they are like all recent stuff. So basically the idea is that GPT-4 can't cheat because it might already know the vulnerabilities in its memory because it's in the training data. But like since these are vulnerabilities found after GPT-4, these are GPT-4 can't cheat and just memorize everything. It has to actually understand these vulnerabilities. So yeah, that's the main thing. And results are pretty interesting. So for GPT-4, it was able to beat a lot of them. But for all the other open source models that they tried, or even GPT 3.5, all of them failed every single one. And for the explanation of why this is, like, I will get there, but like, it's pretty interesting. So there's like a slight suspicion on this paper that I had, and also like this blog post person had, which was they said that they were using, so they said that they were only doing like using open source package CVEs, which is fair because closed source stuff can get patched and we never know like whether it's vulnerable and stuff. This is fine, but one thing that this blog author and I found a bit suspicious was that they said that they only use CVEs that pretty much was reproducible easily, and or that are not difficult to reproduce, kind of. So kind of like basically a translation of this that I personally had was like, basically the authors seem to have chosen the easiest CVEs, which is like exploit disclosures, which basically are designed to like explain step by step how to exploit the given thing. So basically they just made a pretty easy benchmark, arguably. And yeah, kind of like basically this guy, the Chris Wolf guy, kind of like published another blog post on this. But for 11 out of the 12 vulnerabilities, he said was easily found by like public exploits, which was which basically he said that there was like already code and everything available, and was kind of pretty clear like what the steps are. But the main interesting thing of this paper that he found was that he did find that kind of like only GPT-4 was able to beat all the exploits pretty interesting, because as he argues that the reason only GPT-4 was able to kind of successfully beat it is that GPT-4 seems to have an understanding of like browsing the web and like extracting like the key components of the code to use to do the exploits and stuff. Like it doesn't have to kind of like be hand-fed like all the details. It can kind of like extract part of the important parts of the thing to exploit and stuff. So yeah, basically I think that's the main interesting part of this paper. And yeah, so the main conclusion is that this demonstrates that the GPT-4 has a capability of like web searching and extracting like useful information. And also it demonstrates that using React and like tool use, like so like using like web search and stuff can be like pretty useful. But yeah, for this one, the authors didn't publish the code because they said that for ethical reasons, because they didn't want like people to exploit a lot of vulnerabilities, which is fair. So like we can't verify beyond this, I think, because the code isn't available. Yeah. Any questions so far? Oh, interesting. Yeah. They definitely upload pretty good models. Yeah. Function coding is definitely pretty cool, and I think very applicable to here. So yeah, so next they published a paper called Teams of LLM Agents Can Exploit Zero-Day Vulnerabilities. And so here, what's different from before is that for 0 days, the vulnerabilities are not known to the agent ahead of time. So here, the agent has no idea what the vulnerability is. It has to like test the website to see what the exploit is. And this seems to kind of like void all my criticisms of all the previous papers, because here it kind of like goes out of it does enumeration. It kind of finds out what the vulnerabilities are and then exploits them. So it seems to kind of like void all my criticisms. And like the list of exploits that they had were these. And the method they had was basically instead of React, the authors used something called length graph, which is like length chains graphing, which basically kind of like is like a multi-agent approach, basically, where they have like a planner and like a manager, and then it kind of they can delegate to each of these agents, and kind of like basically once this agent is done, it goes back to the manager, which then goes back to the planner, and so on. So, and the reason they did this was that for React, the context length can kind of explode, especially when you're kind of searching for what's the right vulnerabilities. And also it can be like difficult for LLMs to like try a lot of different exploits, which is pretty fair. So it at least seems here that the enumeration takes place. And the design is like each agent has its own exploit at hand and like 5-6 relevant documents for it. So all these agents have one of these exploits and like 5-6 relevant documents to supplement it. And then kind of like the planner chooses which agent, I think the manager or planner chooses like which agent to run next. And then kind of the HTML has all the useless tags like image, SPG, style, and stuff removed. So yeah, basically kind of like this is like no human in the loop. It's like 0 days, so no knowledge of the vulnerabilities ahead of time, and it's basically all the pre-processing of HTML is done, and the planner can choose like which agent to apply and stuff. Basically, it's a pretty neat idea, and the evaluation they did was like this. So like for open source packages like Zap and Metasploit, it had 0% pass rate. With GPT-4 with like no exploit description, it had 20%. With this new method, they had like 50% or so. And like if the GPT-4 already knows the exploit, given like description, it has like actually I'm not sure, like 70% or something. So yeah, it's pretty cool, but yeah. But again, there's a slight criticisms. So you might have noticed a bit, but like this is not necessarily 0 day, at least in my opinion, because they have these 14 different exploits, and each of these agents will have, at least in my understanding, 5, 6, 11 documents for each. So basically there's like 14 actually maybe 15 agents here, and all of them will be experts in every single one of these exploits. And kind of like you might argue like, okay, yeah, in this case, like it only has to choose from 1 from 14, but why can't you just scale it? Like why can't you just put all the exploits in the world into like like each agent and then just scale it? But like the issue is that last time I checked, like all the exploits in the world, there's like 46,000 of them, So like, I don't think it's scalable to have 46,000 agents here where the manager chooses one and stuff. And also like the authors mentioned that, yeah, kind of like authors mentioned that they improved their prior work by 4.5 times, which at least it seems like this, which they pointed out GPT-4 with no description. And basically this is GPT-4 without any knowledge of any of these exploits or like any of these descriptions. So if you give 14 choices of what the exploit can be, I think it's pretty trivial for the performance to increase. But yeah, this is just my opinion. Yeah. So yeah, overall, for the University of like Illinois Urbana-Champaign team papers, I think they put way more emphasis on exploitation than other parts like privilege escalation and enumeration. Because I think they thought that would be like the hardest part of the penetration testing process. But in my opinion, kind of like for exploits, the people who find exploits go out of their way to make like a reproducible description on how to do the exploit. So I do think it's like relatively easy to do the exploitation part rather than the other parts. Yeah. So next, kind of like I will talk a bit about a paper, honestly my favorite paper out of all of them, which is LLM hackers autonomous DNS privilege escalation attacks. And this is a paper by these three authors from Austria. And this is also automated, so there's no human in the loop here. So yeah. Actually, is there any questions? No, okay. So kind of like one question you might have is like, what is privilege escalation again? And like, it's basically like the part of the process where you have like connection to the victim's machine, and then you kind of like look at all the exploitable commands, like for example sudo /l. This is just one example, and then we kind of like go into this upload CLI and view crash reports, and then go to bin bash of the root shell. Basically, it's like this escalating your permissions in the victim's machine. That's privilege escalation. And the main contributions these authors had was they made a benchmark for privilege escalation because they couldn't find it previously. And they also made a Python program to run the benchmark. And also the main interesting part for me was the analysis of like whether LLMs can be used for privilege escalation, because I did find it applicable to like other like what I was familiar with. Yeah. So yeah, kind of like here the tasks are like this. So like SID pseudo files, like exploiting SID vulnerabilities. I think this is like where the vortex one was, the upload CLI. And then yeah, actually you can read some of the ones, but like for example, there are sometimes vulnerabilities where like the pseudo root user uses the same password as like some other user, which is a very bad security practice. Or like root users, it's using the password root, which is a pretty terrible security practice and so on. But yeah, these are like all the methods, all the tasks that they are kind of evaluating against. And then the one interesting one is like clone, which if you're not familiar with it, it's like a process running in the background of like Ubuntu machines, where it does something every 5 minutes or something. So like for example, for here, like a file that you have write access to is called every 5 minutes or something by root. So then you can say, okay, since this root user is running this file every 5 minutes, I can just make it so that the root user gives me more privilege after 5 minutes or something, which is a pretty cool thing to do. But yeah, anyway, yeah, sorry. So the task taken from this try-hack-me privilege escalation training module, which is another popular site along with like Hub and HackTheBox. And yeah, basically it's taken from there, but with like some like useless task remove, like writable etc password etc shadow, which is yeah, basically nobody has them writable anymore, so they were removed. And the main interesting thing that I wanted to point out here was that the authors didn't use like a set version for like OpenSSH and everything, because they said that and they always update all the machines. And the reason for this, they said, was that eventually kind of like you might be just able to like do everything in like a pretty trivial step, because and like the LLM can completely ignore the vulnerability you have and like just get pseudo permissions instantly just because you have like a too older version. So yeah, basically kind of like I think this is a bit of a trade-off where it might make it a bit less reproducible, but on the other hand, like if you don't do this, it'll make like the boxes trivial eventually, basically, because some person will find that will always find an exploit for your current version. Now, another interesting thing that they had was they said that benchmark can have hints, and this is like aberration. So they tested with hints and without hints. So, and the hints is not kind of like supposed to like point to like a specific like vulnerability, but they do kind of like give a bit of intuition. Like maybe we can kind of like exploit pseudo binaries or something like that. So yeah, let's look at the evaluation. So they tried with Llama 2 at the point when I read the paper, and it was only able to do pseudo-odd, which means that you have pseudo privilege for every single command. So the next step is you can just change the username pretty. It's just like one step procedure to change to like a pseudo like a root. Yeah, you can just do sudo su and root. Yeah, and also this is password reuse, where only like stable Beluga was able to beat it, which is like basically the root user is using the same password as like somebody else, and here is like yeah, I'll skip this one, but it's like Docker. It's like a Docker group thing. Yeah. But yeah, kind of like after this, after the last time I checked the paper, by the point I did a presentation, they updated the paper where they used Llama 370B instead of like these things. And as you can see, it kind of performs much better. Oh, I actually kind of like, I think I skipped over some of like how to read this benchmark. So this check mark means that it passed. And this kind of subscript number here is like how many trials for the LLM before it passed. So this means like it took 14 steps to pass. And here the X and the subscript 12 means like the LLM generated like a command that errored out in 12 steps. And for all the others like these, they didn't pass in 40 steps, or pass or succeed in 40 steps. So it's just like nothing happened. Yeah, I think I can go into these history state stuff later. Yeah. But yeah, with Llama 370B, it performs way better. But one thing I wanted to highlight is that, yeah, honestly, it's pretty interesting that it felt pseudo-odd, but like it completely is not able to do any of the clone vulnerabilities. Yeah. And for GPT-4 and GPT 3.5, as you can see, it performs way better. Like for all that pseudo stuff, it seems to be able to do it pretty consistently like this. Yeah. So yeah, let's go to the observation by the authors. So first of all, hints or like intuitions help a lot. So GPT 3.5 increased performance from like 25 to 50% to 75 to 100%. So it kind of drastically reduces the number of round numbers that GPT 3.5 has to do. Like intuition does help a lot. And yeah, basically, and also like another interesting thing is that the amount of tokens generated by OpenAI's tokenizer is smaller than Llama, which means like more kind of information is compressed into each token for OpenAI. But this is the case for Llama 2. I'm not sure for Llama 3 because this is I should revisit the paper here. And for running benchmarks, larger context sizes result in better performance, which seems trivial, but I think an interesting question here is why does kind of increasing context lengths make the results for these models better? And the authors found that for GPT 3.5 and GPT 4, there's different reasons for why increasing context length improves results. So this is like the round numbers, and the max is 40 here, of like the amount of tokens used for GPT 3.5 and GPT 4. So for GPT 3.5, you see that it almost immediately consumes all the tokens in the or the 16K tokens provided to it. So like it kind of maxes out at around, let's say 18 or so, and then it kind of like can't progress from there. But for GPT-4, we see that it's way more like context efficient, where it's able to like put more information into small amount of space. So it can kind of like it barely ever crosses like 8,000 tokens until like round 40. And so the idea here is that for GPT 3.5, it benefits from larger context length because it can kind of like see across the rounds better. But for GPT-4, it basically allows it to go to way longer rounds. So it can go up to round 40, which is why it's kind of like improving in performance. So yeah, and kind of like the reason for why GPT 3.5 kind of like consumes more tokens is that it's kind of filling up the context length with like pretty useless broad commands, like not specific to each round, like PSArgs and like find all the types of file F or something, where kind of GPT-4 executes more like specific commands. Yeah. Yeah. Any questions here? So regarding team of LLM agents can exploit zero-day vulnerabilities paper, how are the agents working internally? Are there some also, honestly, like they didn't provide the code for that paper, so I don't fully know. But they are given like 5 to 6 descriptions of their respective vulnerabilities, and then I think they have terminal access like the previous paper. Yeah. Yeah. So yeah, kind of like I did find that a bit interesting, and also they tested like, what about using RAG and stuff? Like, what about using like pretty trusted cybersecurity like textbook or something to help out these LLMs? And the interesting thing here is that this did not give better results. It increased the quality of the commands for like the LLMs, so that kind of like at one point, I think GPT 3.5, actually GPT-4 was almost able to exploit the clone job vulnerability, but because of like other LLM issues, it failed. But RAG allowed it to almost exploit it, but like it didn't go the final mile because of like some other issues with like the LLM design and stuff. And also like and before we go into these issues, one interesting thing that I wanted to say was like summarizing the state. So like summarizing all the past progress, improve results, but increase the weight cost. So like for understanding which ones are the state, it's like these ones. So this is state, this is state, And for open source models, it's a bit hard to see, but for like GPT-4 and stuff, sorry, I forgot to add it in, but this last check mark means there's a state, and having the state, like using the summarization stuff here, does increase results, as you see. So yeah, but kind of like for sorry, these slides are switched. So for other issues, kind of like for why these models were not able to benefit from like in context learning like RAG and stuff, is that for some issues, like sometimes the LLM just provides invalid parameters, invalid URLs, or like non-existent Docker images, which is not an issue by itself, but it's not able to correct itself. So like, for example, for GPT-4, one time they almost were there, they downloaded a Python binary that kind of like a Python file that can run the exploit or something, and then but the VM called Python free instead of the LLM called Python free instead of Python. Actually, the LLM called Python instead of Python free, and when kind of like the LLM figured out that there was no Python, it didn't try to correct it to become Python free, but it instead offered like a completely different path of like previous escalation. So it ended up failing. So it's not able to like kind of like do these trivial changes from like Python to Python free or something. Also, like for example, even if the LLM can find the password of the root in like some like file, it's not able to make the connection sometimes. Like let's say without human assistance, that okay, this root password. Now that I have this root password, I can try logging into root by just saying username, root, and password. Like even after seeing the root password multiple times, it just kind of like kept on like going like some other route and completely ignored the fact that it already knew the root password. Like so, it doesn't have this understanding of low-hanging fruit a bit. And the overall comparison that they had for humans is that the LLMs kind of lacked a bit of common sense. Like, for example, once you do sudo/l, for a lot of the binaries, you won't be able to exploit them. But like the LLM tries to exploit every single one of those sudo/l binaries independently, even if they know it doesn't work. Oh, actually, I guess it thinks it works, yeah. And also, like for LLMs, like without the ability to like Google search and stuff, it's harder for them to keep up to date. And finally, for like for one kind of praise the authors had was that LLMs can do exploits compared way better than human designed open source tools. However, like it can be a bit dangerous. Like for example, Llama 2, it executed a command rm like remove everything from the user directory, which can be pretty damaging. So yeah, basically there is a bit of risk here. But yeah, overall like it was my favorite paper. And Manil will talk a bit about his auto attack paper. Yeah.
Yeah, there's a question on the chat. Would you wanna?
LLM Junior global scale previous escalation. Do LLMs automate entire cybersecurity? Yeah, kind of like that is a good question, and I think eventually yes, but like at least for now, no. Yeah, like the LLMs need to have a better. LLMs need to have like better understanding of choosing the next task and like making the next tasks and stuff. So I don't think you can at current time do like full automated pen testing without human assistance. Yeah.
Yeah, this is a great segue into the last paper that we're going to cover today. Okay. Um, can you share the
Okay, so
slide?
sorry. Yeah. Yeah.
All right, all right. So this is the last paper. So this is a very good question. So since when we started looking at like couple of papers that discuss LLMs and the hacking with LLMs, and most of the papers love to use the word auto, and it's kind of, you know, people might get the feeling that LLMs are like really not great at, breaching the security on themselves. And the papers that we discussed today, they tend to have mostly focused on the exploitation part, and this auto attacker is not different. This paper is trying to automate the hands-on keyboard attacks, which is saying that, okay, you have, um, for example, in this paper, they mostly talk about the Metasploit, which is an open source framework for the development, testing, and executing of exploiting codes against remote target systems. And they use this meta exploit to, give bunch of exploitation codes in order to maybe breach the security. But as we discussed earlier, the exploiting vulnerabilities, LLMs might be very good at it. Like it's already a known knowledge. It's within the training data set that how to exploit it. But the idea of finding those vulnerabilities, the enumeration, the web enumeration, the file enumeration, finding all of these other loopholes within the system is a very tough task for LLMs to still do. But let's go briefly on what this paper did. Like this paper, like the other papers, they introduced this modular agent design. It's like not a single LLM, but bunch of different agents working together. For example, there's planning, summarizing, and code generation. They also implement this RAG technique where they're trying to incorporate some extra context based on the previously run um, codes in the Metasploit terminal in the shell. Can you go to the next slide? Yeah. So this is the entire workflow of this paper with the introduced. So in this diagram, you can see there are like three main modules. There is summarizer. Summarizer, it gathers the observation, the results of last actions, description of the environment. It just updates the history, creates the summary for the planner. So planner is another agent that just creates a plan of attack. It just this uses the LLM to derive specific actions and outlines the objectives and includes a situation summary and provides the example to guide the navigator. So what's a navigator? The navigator is like, so since this paper fully focused, so they call this paper auto attacker. So they want to, automate the hands-on keyboard attack through Metasploit, the through MSF console, they call it. So what they do in this paper is, for example, you have first of all, you look at the observation, the summarizer summarizes it, updates the history, and the planner then generates the action, provides the action situation, and looks at the output based on the action, stores it in the memory, and does the RAG on the experiences that it had earlier, and to select the most probable related action for the next task. So, can you go to the next? Yeah. So in this paper, they focus on known vulnerabilities that they had. Like for example, the machine that they were attacking, they might have like file writing, they might have tasks of privilege escalation, credential stealing. So these are the basic tasks that they are focused on exploiting. But on the right, you can see that GPT-4 was able to, the SR means success rate, and IN is for interactions, the number of interactions. And you can see that GPT-4 was able to, successfully exploit all of these vulnerabilities within the machine. Now, this looked a little suspicious to me. Like, is GPT-4 that good at, automatically hacking into a machine? So this brought me like to the point that okay, it's not automatic hacking at all. It's exploiting some vital information. It's exploiting a known vulnerability, but auto attack, that's debatable. So let's go to the next slide. I want to talk a little bit about um, why this this whole research area where is might be a little lacking, and where the research community might need to focus on next, because the word auto suggested that okay, the system is capable of automating like end-to-end attacks. And since as if you recall the walkthrough that I gave you, most of the time you are spending to enumerate the machine. You are enumerating, you're exploring for the known if there is any vulnerability. But after you know it, like exploiting it, it's excellent. You can see from the previous slide, it was very good. The LLMs are good at exploiting the vulnerabilities after you know it, right? So now, also another one of the main critics that I had of this paper was that there is no any sort of long-term planning on the attack. It just creates the sub-steps. It executes the command for the sub-step for exploiting a given vulnerability that what we discussed in the earlier table. And attacking a known vulnerability does not mean auto attacking. So the name of the paper for me, it was kind of a misnomer given the broad scope of task in penetration testing. They focus on metasploit. They focus on the framework, and they stick on it. It's fine. It's a small part of a giant the whole procedure of making LLM autonomously attack a machine. So it's a small part where they demonstrated that it does really well given their pipeline. And also they also mentioned that they developed a benchmark, but it was I don't see it released. I tried to find it online. The paper does not mention where it's released. But the thing is, like, uh, from bunch of the papers that we've read, the conclusion that I had from the lit review was that okay, this LLM as hackers is still a long way to go if we want to do it autonomously. And yeah, the summary, I think Chad will take over for the summary and some of our research directions.
Thank you, Manil. And yeah, so for the conclusion for the literature review, yes, sorry for the pretty technical hacking stuff, but the main thing that we wanted to highlight is that there's like a lack of like benchmark or like understanding of like which areas LLM is best to versat. And kind of like one assumption that I think we both have here is that enumeration and like long task planning context utilization is the hardest part, but we do not know that. So there is a, and like for example, for the University of Illinois Urbana-Champaign, the authors thought that the exploitation was the hardest part. And for auto attack, it thought like the specific each subtask is the hardest part, and didn't think long-term task planning was important. And for pen testing, like they didn't think like human involvement will be a too huge issue. So like I do think there has to be like one benchmark or something where we can evaluate pen testing agents against to have like a detailed understanding of which part LLM agents are best at and which part LLM agents are worse at. And also another thing that I wanted to highlight is like, is auto attacking even like a feasible thing, or like kind of like another important thing is like, it seems like auto attacking by itself doesn't seem to be too like too promising to hack into like pen testing machines. But what if you are like a normal person and you can kind of like say, oh, I see like a login page with like a sign and like username and password. What should I do? Like, what if you just have like a normal level understanding, and then can tell that to the LLM, and the LLM just like tells you the next steps? Is that possible? Like, it's like a pretty unbiased evaluator who isn't too knowledgeable in pen testing with a LLM like possible to like hack into machines? I think that's still like an open question to be answered. And for like one note for what we are trying to do, we are trying to like make like an open source bound hub benchmark. So no like hack the box thing, since like eventually all active machines will go into like the retired state, so it'll be like $14 per month or so. And then we plan to like evaluate it versus GPT, Pentest GPT, Llama 3.1, and some other improvements that we thought. And yeah, we plan to like release a paper there. But yeah, that'll be a bit in the future, but we might do another presentation after that for what we found. But yeah, overall, yeah, that's about it for it. Is there anyone with any questions? No problem. Yeah, no problem. Yeah, for the benchmark, we are mainly kind of like, unlike kind of like, the reason we are trying to evaluate Pentest GPT here, or like compare a study to Pentest GPT, is mainly because we are interested in how it performs without like pen testers' assistance, kind of. But yeah, we weren't able to do it fully automatically. So kind of like there's a bit of a interesting question there. So yeah. And is there research on fixing vulnerabilities in code using? Yes, I'm pretty sure there was. Like, yeah, let me ping you later, because I remember there was like a GitHub with a lot of mentions of stuff like that, and also I think there was a paper on like the opposite way, where it tries to like create malware to like bypass security software iteratively and stuff. Yeah. Oh yeah, and also feel free to raise your hands if you want to talk. But yeah, either chat or in the chat will be fine too. Yeah, am I recording? Yeah, I'm recording. Good. Oh, and sorry for going 30 minutes over. Oh, so unlocking LLM, I think you mean like jailbreaking. Kind of like, I don't think it's like too important. Like, you can just say like you are like a certified pen tester in like a cybersecurity environment where you kind of like attacking a local machine and you have full permission, and you're pretty much fine with like you're pretty much fine with like being able to do all the hacking steps. Like that's what Pentest GPT did, and we are just following that. Oh, and thanks a bunch. Yeah, honestly, like at least for the workflow, I thought it would be too technical, because at least for me, it took me like 6 months to understand every step. So I'm glad you guys understood it. Yeah.
Thank you everyone for tuning in. It was a great presentation by Chad.
And no, you did great. But yeah, thanks a lot for tuning in. How can we control guide LLMs or LLM agents to simulate pen testing without? I think like for pen testing, you should always do it on like, let's say virtual boxes on your local machine, or like or hack the box, at least for this research. But yeah, like when like humans do pen testing, I know at least I heard from like a pen testing friend, you have to like be sure not to do like DDoS commands, or like be sure not to like do like, yeah, like stealing people's passwords. You only want to exploit services and stuff. So that is how you avoid it. But I think for like these research, you want to always use like local or like hack the box or something. Oh, yeah, kind of like one example that actually one example that we have is like that we are making now is like this, where you have like Barnham machines, and then you have like a step by step on like we want to do network scanning, and this is the command for it, and this is the output, and we want to navigate the website and like find these pages. We want to do like SQL map. We want to SSH in the server and check permission. Like this is like a very easy box version, but like it's kind of like that. Basically, it's like steps on how to beat the machine, kind of. And thanks for everyone for listening. And yeah, if you go to Barnhub or there's like so many good virtual boxes. Yeah, but kind of like one critique I have on Hub is that a lot of the boxes are like pretty game-like, where it's not realistic. So like you have to do some sort of like filtering to like find like the right ones or like realistic ones, basically. And I think those will be the most important. Keywords, I'm not sure what that means, but yeah, that would be good. This is some similar concept. Probably I'll document my questions. Oh yeah. Happy to answer any questions. And yeah, I think we are like close to wrapping up. Yeah. Okay then. Yeah. Does anyone else have any final questions? And yeah, again, thanks for coming. Enjoy. Okay. Well, hope you all have actually some people are typing. Has anyone given you a hassle for being so public about it? Not so far, but I don't personally see an issue with it because I don't know. I feel like all the LLMs suck currently for doing any pen testing, so I don't think you'll be going anywhere. Like, yeah. Basically, the main thing our research does is it just shows that LLMs suck at pen testing. But yeah, thanks again, Joe. And okay, yeah. Does anyone have final questions? Okay.
Yeah, I just wanted to put the final thought, like the whole idea of if LLM is able to do it everything by their own, it's just gonna make your networks, your computer, your server security much better, because you don't need like a pen tester trying to hack into it just to fix the patches. I guess that's also one of the points that I wanted to make. Not just hacking, but making the networks more secure. That's, I think, the ultimate goal of this field.
Yeah, that's a great point. Basically, our goal is auto pen testing. So the final result should be like corporations will be able to pen test the network to be sure that they are like completely secure against hackers. And currently, like pen testing takes a lot of money. Like you have to like spend so much money. You have to be like a Fortune 500 company in order to do pen testing properly. So like, so yeah, having it all done by LLMs will be good. But yeah, overall, thanks everyone for coming, and yeah, hope you all have a great day. Oh, Contra, do you have a final question? LLMs for intrusion detection. I think there was papers like that, but we didn't cover it. But kind of one idea is like one idea that we were having for like LLM reinforcement learning was like there's like stuff like red team, blue team in like the hacking world, where like one team tries to take down services while the other tries to keep them up. And if you can kind of like, I don't know, maybe like do reinforcement learning like chess like that, it might be cool. They might like progressively improve. That's just for the future, and we are not sure if it will work. Yeah. But yeah, overall, thanks everyone for coming, and I think we will end the event here. But hope you all have a great day.